Okay, what do millennials around the world want in a job? And it says they're looking for stability in an uncertain world, with 60% of millennials preferring a permanent full-time job. So point 6 is pi. And the first part, n, is 100. Now, I'm up here. Okay? And part A says find the probability, what is the probability that in the sample fewer than 67%? So fewer than 67%. So I had to find my z, and I'm not going to repeat this every time, but your z it's your p minus your pi divided by your standard error, and that's pi times pi minus 1 minus pi over the sample size. In this case is 100. And that gave me a z of 1.43. And I drew my picture here. I used my chart and got 0.9236. Part B, you're trying to find the probability that you're in between a 0.57 and a 0.67. So I had to find a new z for this 0.57. Your denominator never changes. I got a z of negative 0.61. Here's my picture. I used my chart, and I got 0.6527. And the way I got that 0.6527, I used page 2 of the chart minus page 1 of the chart. I found the probability of less than 1.43, and then I found the probability of less than negative 0.61 and found that difference. Part C says what's the probability that it's more than 0.62? Had to calculate a new z, and I got 0.41. Here's my picture. Gave me 0.3409, and that's part A, B, and C. Part D says if a sample of 400 is taken, how does this change your answers? Well, here's my work, the second column, if I can find, right here, and my pen has stopped working. There it goes. So this is my part D on the right, and you repeat the process exactly like we did before. It's that now my sample size is 400. So my first z was a 2.86. Here's my probability of 0.9979. This time we're doing in between a 0.57 and a 0.67, so we're using the same denominator every time, where your sample size is 400. I had to get a new z for 0.57, and I got negative 1.22. So this is what I'm trying to find, and that probability is 0.8867. The last one, you're trying to find the probability it's greater than 0.62. I found a new z, and the area corresponding to that is 0.2061. So I entered in my answers, and I also here is the value of my standard error when n is 100. And here is my standard error when n is 400. So if you take 0.02, if you take 0.245, 0.0245, and you multiply that by 2, you get this. So an increase in sample size has decreased the sample error, causing the value of the answers in part A. We'll just compare this answer to this answer, and it increased, and this one increased, and the last one, you're further in the tail, so it's going to decrease.